welcome to today's lesson on histograms. So, first of all, we're going to talk about the difference between a bar chart and a histogram. Because a lot of people think they're the same, but they're actually completely different. So, a histogram uses continuous data, so this is anything which is measured. So we're thinking about here, well, time, which is in this example, your height, your weight, anything which is measured is continuous data. We use histograms for this. And bar charts uses discrete data, so this is anything which is counted. So this might be your number of siblings, the number of sweets that you have. Anything which you count is discrete data. Now, with histograms, you also have sometimes have uneven bar widths, and this is a problem as well. Let's have a look at this one here then. So have a little look yourself. Why do you think that this bar chart is misleading? See if you can spot why it's misleading. Okay, so let's come back to it. So the problem here is that second green bar there, which is between 1 and 5, they've actually only caught 3 fish in that time. But because it's spread out over time, the area of that bar is the biggest, and actually it looks like the biggest part, doesn't it? However, the issue is that it makes sense that actually only catching 3 fish over 4 hours isn't very good. And actually looking at that first part, which is the smallest, the thinnest part, we've actually caught 4 hours in that first hour, so that was the best part. And it just doesn't look right in terms of that middle bit's the biggest, but actually it's the smallest amount of fish caught. And this is one of the reasons that we use something called a histogram. So, the area of the bars gives a false interpretation of the amount of fish caught. So this is why we use bar charts, and histograms are when we use bars of unequal width or continuous data. Now, this formula here is really important. Frequency density is equal to the frequency divided by the class width. Now, this is really, really important. It's worth getting that down in your notes because you'll use that all the time. I'll actually draw a little triangle for you in a second to show how you can use this for different things. I'll go through a proper example, but just to show this one here now. So the frequency density is going to be your height, and this is what we're using instead of the frequency. So here, to find out our frequency density, which is the height of our bar, we do the frequency, which in this case is 4, divided by the class width, which in this case is between 0 and 1. So the width of the class is the width of the time. So how far is it between 0 and 1? So 4 divided by 1 is 4. The width of this one is between 1 and 5. So between 1 and 5 is 4. So it's 3 divided by 4, which is 3/4. And then this one's going to be 4 divided by, well, between 5 and 7 is 2. So the 4 divided by 2 is 2. And then we have this one here, which is our histogram. And you can see now that actually looking at that, you can see that the green area is the smallest. You can see the blue area is the biggest. And actually the red area over there, it looks more accurate. It makes more sense to have it like this. And you can see that really clearly. So that's just a little introduction. We're actually going to go through and have a go at a histogram question now. So let's move over to our first question. So it's worth, first of all, getting down the triangle for histograms so we can work out any part of it. So it's a formula triangle that we use, and we know that the frequency density is equal to your frequency divided by your class width. It's definitely worth getting that down in your notes, okay? Because we use this all the time in this little section here. So if you want your frequency density, it's frequency divided by class width. If you want your frequency, it's frequency density times by class width. Or if you want your class width, it's going to be frequency divided by frequency density, and you'll use that all the time. Now, I'll come to get this again later, but the key part for this, and the key part for any histograms question, is that the area represents the frequency. That's so important. In fact, I'm going to start. I'm going to ask you to get that down in your notes. So the area of each rectangle, represents the frequency. That's so important as well, okay? As long as you know these two things and you've got a good grasp of this, then these questions do become quite easy. So let's have a go at this first one here. Now I'm going to draw it out. We're going to draw this histogram. So here we've got Julia and she's measuring the lengths of rooms. So let's draw out the table first of all. Do make sure you're getting this down as well. Remember, the only way to learn maths is to do it. So we've got our table there. We've got lengths at the top up here, and that's in centimetres. We've got frequency there, and we've got frequency density over here. Now remember that we are using frequency density as the height, as it's a better representation when we're using when our widths aren't even. Okay, so our first one here is between 250 is less than or equal to x is less than 300, and then 300 is less than or equal to x is less than 320, then 320 is less than or equal to x is less than 330, and then 330 is less than or equal to x is less than 340. And we have our frequencies here, which is 25, 100, 30, and 10. Brilliant. So what we're doing here is we need to work out our frequency density, okay? And we know that the frequency density is equal to your frequency divided by your class width. Now your width is the width of these ones here. So the width of this first one between 250 and 300 is equal to 50. So our first one is going to be 25 divided by 50 for our frequency density. This one here is going to be equal to, let's move that off a little bit, 300 divided by the width of that there is 20, between 300 and 320. Between 320 and 330 is 10, so 30 divided by 10. And then 330 to 340 is 10, so 10 divided by 10. And this will work out our frequency density, which is going to be the height of our bars. So 25 divided by 50, now be careful with that. 25 divided by 50 isn't 2. 25 divided by 50 is actually 0.5. 100 divided by 20 is 5. 30 divided by 10 is 3. And 10 divided by 10 is 1. Brilliant. So we've got our table there now. We've got our frequency densities. So now we've actually got to draw our histogram. So we're going up by maximum 5 here. So I'm going to do 5 lines up. And I'm going from 250 to 340. So that's over by 250, 260, 270, 280, 290, 300, 310, 320, 330, 340. That's 9 across, I'll say. So let's have a go at this. Now, again, I'll say this. It doesn't matter what you're going up by as long as everything is equidistant. So as long as you're going up by the same amount. So I said I want 5 up. So let's do that here. 5 up there, and I need 9 across to get from 250 to 340. So I'm going to use the inches on my ruler. So there, 9 across. 1, 2, 3, 4, 5, 6, 7, 8, 9. Super. So I'm going up to 5. So 0, 1, 2, 3, 4, 5. I have got 6 there. I don't need it. Now remember that this is your frequency density, not your frequency. And here we're starting at 250. And we go 250, 260, 300, 270, 280, 290, 300, 310, 320, 330, 340, super. Okay, and that there is our lengths of the rooms, isn't it? So that's the length, and that's in centimetres. Super. So now we need to plot our width of the length, so this width here, so between 250 and 300, 250 and 300, and then a frequency density is how far we're going up. So this is going to be 0.1. So if I'm doing this one here, so between 250 and 300, and up by 0.5, so let's go across here. 0.5 is going to be halfway between that, there, and then I'm going up by 300, which is there, like so. Now remember, if you're doing this, make sure you're using a pencil. I'm using a pen because I can rub things out if I make a mistake. So the next one is between 300 and 320, and then up by 5. So between 300 and 320, up 5. So let's do that one there. Try and make sure it's as vertical as possible. So up by 5, and over to 320, and up by 5 again. Across there, brilliant. So that one's 300, 320 up 5. The next one is 320 to 330, and that's 3. So up to 330 there, and then across by 3. And then that last one is 330 to 340 and up by 1. So here, like so, and then up by 1, brilliant. So there you've got your histogram. Now, you don't need to do this next part for this question, but it will help us in the future. So the thing that we need to remember, and I'm going to keep hammering this, is that the frequency is represented by the area of these rectangles. So what do I mean by that? Well, the frequency of this first one was 25. And we know that the area of this, so between 250 to 300 is 50, times by 0.5, the area of this rectangle is 25. 50 times by 0.5. If I'm looking at this next one, so this one here, this has got a width of 20. It's got a height of 5. 20 times by 5 is 100, which is the same as the frequency. The area is the frequency. This next one here is 10 across, and then up by 3. 10 times by 3 is 30. So the area is the frequency, which is 30, and then 10 times by 1 is 10, which is our frequency again. Brilliant. That's really important to know that. Okay, so I'm going to put this next one up. Pause now and have a little go at this one yourself. So pause now and have a go at that one on the right yourself. Okay, so let's have a little go at it together then. So we've got our table first. Let's draw that across here. How many going down here? Okay, so there. And then this one here. And what are we looking at this time? We are looking at Sean, the mass of some cake, mass of cake. So we've got mass here like so, and that's measured in grams. We've got frequency here, and remember we've got to work out the frequency density, which is our height. So we draw our masses in. So 5 is less than or equal to x is less than 10. 10 is less than or equal to x is less than 20. 20 is less than or equal to x is less than 25. And 25 is less than or equal to x is less than 50. And as we go up here, we've got 30, 15, 20, and 25. Now remember, we've got to work out the frequency density, which is going to be the height of our bars, and we do that by doing the frequency divided by the class width, which is there. So this first one, the width is between 5 and 10 is 5. So 30 divided by 5, which is going to be 6. Between 10 and 20 is 10. So 15 divided by 10, which is 1.5. Between 20 and 25 is 5. So 20 divided by 5, which is 4. And between 25 and 50 is 25. So 25 divided by 25, which is 1. Brilliant. So we've got our table now, and now we need to draw our histogram. Okay, so this time we've got a height of 6. Okay, so that's fine. And we're going across between 5 and 50 here. So between 5 and 50, let's go up in multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, that's going to be 9 across. So I need to go up by 6, across by 9. Again, it doesn't matter what you go up by, as long as it's uniform going up, so as long as it's the same. So I need to go up by 6 here. Let's make sure you can see that. So I need to go up by 6. Brilliant. So they're up by 6. So 1, 2, 3, 4, 5, 6. Super. And I need to go across by 9 because I'm going to go up in 5s. There. I'm using inches. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Super. So we're going up to our highest frequency density is 6 there. So I'm going up by 6. So 0, 1, 2, 3, 4, 5, 6. And this is our frequency density. Okay. Across, we're starting here at 5, aren't we? So it starts at 5, 5, 10, 15, 20, 25, 30, 35, 40, 45 and 50 there across. Super. And that there is our mass, isn't it? And that's in grams. So our first one here is going to be, well, it's between 5 and 10 and up by 6. So I'll do this in a different colour just to make it nice and neat. So between 5 and 10 and then up by 6. Between 5 and 10, up by 6. So let's do the up by 6 first. Doing it this way. Make sure it's nice and neat, really straight, up by 6, across 5 and 10, brilliant, there's our first one. So the next one is between 10 and 20, up by 1.5. So between 10 and 20, up by 1.5, so let's do the up first. So up by 1.5, which is in the middle between 1 and 2, and then across there like so. There's our second one, super. Now the next one's between 20 and 25, up by 4. So between 20 and 25, up by 4 this time. 25 I'll need as well. Super, like so. And then the last one is between 25 and 50, but only up by 1. So between 25 and 50, up by 1. Make sure that line's nice and neat. Brilliant, and there's our histogram. Now remember, the important part here is that the area of each of these rectangles is represented by the frequency. So the first one, 5 times by 6 is 30. 10 times by 1.5 is 15. Now we've already got all of these. This next one is 5 times by 4, which is 20. And 25 times by 1, which is 25. So the area is represented by the frequency. And as I said, that's so important. Okay. Let's move on to the next question. Now, I think the next question is actually a little bit in fact, sorry, we need to check these first, don't we? So let's check these answers. Brilliant, brilliant, super. So this next question is actually a little bit easier because you don't need to draw anything with this one. So this next question here says, the histogram gives the information about the times in of 135 students and how long they spent on the internet last night. Use the histogram to complete the table. So with this one here, the thing that we need to spot is that we're trying to work out the frequencies. Now, like I've hammered and like I've just said to you, the frequency is represented by the area of each of these. Okay, so all we need to do is find the area of those rectangles. So, I know it's quite tricky to see. I'll make it big so you can see it. Let's make it nice and big. Okay, so here we've got our first one. So the width of this first rectangle is 10. The width there is 10. And the height is 2. So the first one is going to be 10 times by 2, which is equal to 20. So it's, you follow my mouse here if you want. It's 10 across, up by 2, which means that it's going to be 10 times by 2, which is 20. This next one is between 10 and 5, so that's 5 across, up by, now I know this is hard to see, but that is up by 3.6. So it's going to be 5 times by, let's just check that, 3.6, whatever that is. So 5 times by 3.6, which is 18. Now the next one is between 15 and 30. So it's 15 across there, and it's up by 3. So it's going to be 15 times by 3 for the frequency. So that's 15 times by 3 is equal to 45. And then the last one, between 30 and 50, is equal to 20 across. So 20 across there. And it's up by, well, this one's up by 2.6. So it's going to be 20 times by 2.6. So 20 times by 2.6, which in this case is equal to 52. Now we can actually check that, can't we? Let's just go snap back to that so you see the working that I've done. So we can check that, can't we? Because it tells us that the total is 135. So if I go 120 plus 18 plus 45 plus 52, 135, yes, I've got it right. All my axes are brilliant. Let's just check that answer. Super, and we've got it. All right, so I've got another question here. There's a little trick for that second part, but pause now and have a go at that question yourself. Pause now and have a go at that question yourself. Okay, so let's have a go at this one together. Now we're trying to find out the frequency of that first bar. And we know that the frequency is represented by the area. So important. So what's the area of that first rectangle? Well, it's 100 across, isn't it? And the height of this one is 0.9, isn't it? So it's 100 times by 0.9, which is equal to 90. So that first area, the frequency in that first one is 90. Now we notice that for the second one we've got to find out, between 300 and 500, we don't have the bar on there. And you're thinking, well, how are we meant to do it without the bar? But because we know the total, because we know the total is 800, and we know all of the other bars, we can work that out by doing 800, take away all of these. So it's going to be 800, subtract 90, subtract 150, subtract 140, subtract 120, subtract 20, which is equal to 280. So that one between 300 and 350 is, so between 300 is less than W, is less than 500, is equal to, the frequency is 280. Remember, that means the area of that there is 280. Okay, let's just check those answers. Brilliant. Super. So, now you might look at this one and you might think to yourself, I'll make it big so you can see. Well, this one's just exactly the same as the others. All I need to do is to work out what those areas are. Really easy, fine. However, there is a little trick with this one. And the little trick is that you don't know what the frequency density is on the side. Now, this is quite tricky to work out if you don't have the paper in front of you. I'm actually going to draw on this now and show you how to do it. But try your best on the screen. I know that it's difficult, but just try your best. I'll show you how to do it then. So, okay, so I've taken a screenshot here of the graph and only the first three, because we're actually going to be dealing with the first three from the bar chart. So the first thing we need to know is the fact that the frequency is equal to 30, and we know the frequency is represented by the area. So because we don't know what this frequency density is, we are using the frequency to work out what it is. Now we know this first one here, don't we? We know what the frequency is, and we know what the class width is. So what we've got to do is we've got to use this to find out the frequency density on the side. So we know that the area is represented by the frequency. So the first thing we can write in here is that this is 30. We know that that's equal to 30 because it's the area. We know that this here, across here, is between 100 and 130, which is also 30 across there. So we know that that's equal to 30. So if we know that the area is 30 and the width is 30. To find out the height, which is going to be the frequency density, is going to be the area divided by the width. Now, it's tricky to explain here because they're both 30, but the area is 30, which is the frequency, and the width is 30 as well. So it's 30 divided by 30, which means that this is 1, okay? So we know that the height of it is 1, because 1 times by 30 is 30. So if we know this height here is 1, we can then start putting on all of the rest. So the next one height here is 2, then it's going to be 3, then it's going to be 4. Do that again. So that one there is going to be 4, then it's going to be 5, then it's going to be 5, then it's going to be 6, then it's going to be 7, then 8 here like so. And we use what we've got here to draw our frequency density on. So we're using that first one to find out what the frequency density is, okay? So once we've got that frequency density, then it becomes really easy because we're just finding out the areas of these rectangles. So the area of the first rectangle is between 130 and 150, okay? Sorry, the second rectangle, sorry. The area of the second rectangle is between 130 and 150, which is there. Okay, now that there's a width of 20, isn't it? So it's going to be 20 divided by, now, we're going up here. Now we're going up to 4, aren't we? Well, there's 1 extra square, and 1 is split up into 5. So we're actually going up here by 4. Again, we're going up here by 4.2. Okay, get that there. 4.2. It's not come up very well, but you can see that there. 4.2. So 20 times by 4.2 is equal to, well, let's work that out. So 20 times by 4.2. 20 times by 4.2 is equal to, this area is equal to 84. Brilliant. Okay, so that the area there is 84. So this next one is going to be, well, it's between 150 and 160, so that's 10. Okay, so that width there is 10 across, and the height of this one is 1, 2, 3, 4, 5, 6 up. So it's going to be 10 times by 6. 10 times by 6, which is going to be equal to 60. Right, again, 60 there, like so. Brilliant. So we know that this one here is 84, there, like so. Let's move that out of the way. 84. And this one here is 60. Okay, and it's tricky to work that out because we've got to work out that frequency density first. Okay, so we've got to work out this height here, and we do that by using this first one here, don't we? So we use that by working out what the frequency density is from that first one. Okay, so let's just check that answer then. Okay, so let's just check that. So 84 and 60, brilliant, yeah, well done. Okay, so let's have a go at this next one. I'll make it big. Pause now and have a little go at that yourself. See if you can. So pause now and have a go at that yourself. Okay, so I've got a screenshot here of the histogram so I can draw on it. Now, the first thing that we need to remember is the fact that the frequency is represented by the area. Now, which one do I know the area of and the frequency? Well, I know the area of this 2 to 10 one, and the frequency of this 2 to 10 one is here, which is 120. So this is the one that I'm going to use. So straight away, I can write in here that the area is equal to 120 there, like so. Super. So the next thing I need to consider is the fact that the width is between 2 and 8. So the width of this is 8. Brilliant. So remember, I'm trying to find out the frequency density of this. I'm trying to find out what this, the left-hand axis is. And I can do that by working out what the height of this is. So I can, if I know that the area is 120, and I know that the width is equal to 8, to find out the height of this, it's going to be 120 divided by 8. So I know that the height of this one here, take it across, is 15. So that there is 15. So I know that that height is 15. Now what I need to do is I need to work out what each square is worth. And I do that by counting up how many squares there are and dividing by the height of 15. So in this case, there's 1, 2, 3, 4, 5, 6, 7.5 squares up. So if there's 7.5 squares up, 15 divided by 7.5 is equal to 2, which means that each of these squares here are 2. So 2, 4, 6, 8, 10, 12, 14, obviously halfway there is 15, 16, 18, and 20. Brilliant. So I know what my axis is here. It's not very clear there. I should probably use text for that instead. But so I know that it's going 2, 4, 6, 8, 10, and I've worked that out by working out what the frequency density is of that first rectangle. So next up, if I want to work out this one here, which is between 15 and 20, then what I need to do is I need to work out the area of this. So I know that the width of this is between 15 and 20, which is 5. I know that the height of this is up to 8, because it says there 8. So 5 times by 8 is going to be equal to 40, which I know is the frequency, because the area is represented by the frequency. It is tricky, that. It is tough. Let's check and make sure we've got that right. So let's just check that. So that's 5 times by 8, which is 40. Brilliant. So let's have a look at this next one now. Now this next one is tricky again. Okay, I'm going to make it big. Pause now and have a little go at that if you can. So pause and have a little go at it. If you're struggling, then wait and I'll go through it now. So I've got the screenshot here for us to have a little look at. So this first line is the really important line. It says that 16 students here is between 10 and 15. Okay, so if I look between 10 and 15, well, that's going to be here, isn't it? Between 10 and 15, which is there. So I know the area of that rectangle there must be equal to 16 because the frequency of it is 16. Okay, now remember, I'm trying to work out the frequency density, which is on that left-hand side. And I can do that because I know that the width is equal to 5, and I know that the height is equal to, I know that the area is equal to 15. So if I want to work out that height on the side, it's going to be the area, which is 16, divided by the width, which is 5. Now what that tells me is that each one of these lines, 16 divided by 5, the height of this is equal to 3.2. So if I go across there like that, like so, not done that very well, that there is 3.2, okay? I know that that line straight across there is 3.2. So the next thing I need to see is how many blocks up is that? So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 small little blocks up. So if I want to work out what this is, I'll work out what 1 block is, and then I'll times it by 5 to find out for 5 blocks up. So 3.2 divided by 8 is going to be 0.4. So every single one of those little tiny blocks is 0.4. But if I want 1 full block of 5, I'll times that by 5. So 0.4 times by 5, which is equal to 2. Which means that each one of these, is 2. So I'll rub that out. I know that the height of each of these now is 2. So I can go 2 there, 4 there, 6, 8, 10, 12, 14, 16 at the top there. Okay, that is the really tricky part. I'll just go through that one more time. So here I know that the area of that third one along is 16. I know that the width is 15. I know it's 16 from this part here, don't I? And I know the width because it tells me it's between 10 and 5. So The area is 16, the width is 5, so I need to find out the height of that, which is 16 divided by 5, which is 3.2. So 8 squares up is 3.2. 3.2 divided by 8 gives me 1 square. 5 squares up times by that, which gives me 2. So each 5 of these squares is 2 up. Now, I've not finished there because the question actually says, what is the area? Sorry, what is the total frequency? So if I want to work out the total frequency, I've got to work out the area of each one of these rectangles. So let's do that then. I'll do this in red. So the first one is going to be 5 times by 4. I'll do it on the graph. 5 times by 4, which is 20 for that one there. Brilliant. The next one, so that's 5 there, times by 4 up. The next one is 5 times by 4, which is 20 again. This next one is 5 times by 14. So 14 times by 5, which is 70 in that case. This next one, I've already got that one there, which is 16. This next one is 1, 2, 3 up. 3.8 up it is, okay? In fact, I can go along here, can't I? So it's going to be 6. Now remember that each one of these little boxes is 0.4. So 6, 6.4 here, there. 6.4, 6.8, 7.2. And then it's going to be 7.6 is this line across here. Now this is tricky to see on there, but that there is 7.6. Okay, so it's going to be 7.6 times by 5, 7.6 times by 5, which is equal to, this one here is 38. It's quite tricky to do that one. And then these ones here are 2.4, because it's 6 up. So 2.4 times by 5, 10, 15. 2.4 times by 15, which is equal to 36 for all 3 of those. So 36 there for all 3 of those. To work out the total frequency, I'm going to add all these together. So it's going to be 20 plus 20 plus 16 plus 70 plus 38 plus 36, brilliant, which is 200. So that's a nice round number, which gives me a little indicator that this is right. It's not always the fact that it's nice though. Alright, brilliant. Hard question, that's really hard. There's loads going on. That's probably worth about 4 marks or even probably 5 marks at GCSE, which is loads, okay? So do take your time in understanding it. So let's check that answer. 200, brilliant. Okay, so I think that they're probably the hardest questions. We're going to have a go at a couple more, just a little bit of an end part, which is the proportion part of this. So let's have a look at this next question. So, a histogram shows the information about the number of minutes some people waited to be served at a post office. Work out an estimate for the proportion of people who waited longer than 20 minutes to be served. So I've zoomed in on this again. Now, it's asking for the proportion now of people who will be served. The first thing we've got to do with this, again, is to work out the total amount of people, okay? So, if we look at this, the total amount of people, we're going to have to work out the area of each of these, aren't we? So we do that by the class width times by the frequency density. So this first one is going to be, how far across is that? Well, it's going to be 5 across from there to there. So half of that is 2.5. So this is going to be, it's going to be 2 across there. So it's going to be 2 times by 2.5. So the area of this first one is 5. The next one is going to be between 2 and 5, which is 3. So here across is 3. So it's 3 times by 4. The area of this one is 12. So this next one is between 5 and 10, which is 5 across there. So 5 times by 3.4, that is. 5 times by 3.4, 5 times 3.4, which is 17 for that one. This one here is going to be between 5 and 10 times by 2.2. So 5 times by 2.2, which is 11. And this last one is going to be 15, 5, 10, 15 across. So 15 times by 1, so the area of this one is 15. Brilliant. So now I know the total of all of these, the total frequency, which is going to be 5 plus 12 plus 17 plus 11 plus 15, which is 60. Brilliant. So the total frequency is 60. Now, it's not asking just for the total frequency. Sorry, you can't see that, can you? It's not asking just for the total frequency. It's asking for the proportion of people who are over 20. So if I want to look at the amount of people over 20, I've got to find all of the areas which are over 20. So what I do is I draw a line on there like so, because this area here is the part which is over 20. So what's the area of this going to be? Well, between 20 and 30 is 10 there, and the height of this is 1. So in which case, it's going to be 10 times by 1, which is 10. So the area of this is 10. Brilliant. So I know that there's 10 people over 20 out of a total of 60. So the proportion here is going to be 10 over 60, which is going to be equal to a sixth. Okay? Again, that is tough. That is tricky. Okay? But they do come up, and they will come up like this. So let's just check that answer. So here, 1 over 6, yeah, good. That's worth 3 marks there in total. You've got to work out all of the areas. Look, you'll see that they've done that here, and then work out the last part. So one more question to go. So here, we've got a histogram that shows the information of the times taken from a call centre. Work out an estimate for the percentage of people who answered in less than 40 seconds. So let's zoom in so I can draw on this histogram again. So very similar to our last example, we need to work out the total frequency first, and we do that by working out the area of all of these. So the first one is going to be, well, between 0 and 20 is 10 there, isn't it? So this one here is going to be 10. So it's going to be 10 times by 3.1. Up to here, this is 3.1. So 10 times by 3.1 is 31 for that first one. This next one, between 10 and that's 30, isn't it? So between 10 and 30 is 20 across. 20 times by 2.2 is equal to 20 times by 2.2 is 44 there, like so. 44 there for that one. So this next one is between 30 and 60, which is 30 across, and that's 30 times by, well, that's 0.9. So 0.9 up. So 30 times by 0.9 is equal to 27 for that one. 27. And this last one between 60 and 120 is 60, and that's times by 0.3. There's 3 up there. So 60 times by 0.3, which is equal to 18 there. So let's work out the total of all of these. So 31 plus 44 plus 27 plus 18 is equal to 120 for the total. Brilliant. So we've got our total now. Now remember, it says it wants the estimate for the percentage of calls which are less than 40 minutes. So let's change my colour now. Let's change it to green. And we're looking for everything which is less than 40. So I've already got 2 of the areas which are less than 40. It's this 31 here and this 44. The only thing I don't know is this little area here, which is part of that next one, because the full one is 27. So to do this, I do the width of this, which is going to be between 30 and 40, which is 10. 10 times by 0.9 again. The area of this one here is equal to 0.9 times by 10, which is 9 there. So for every one which is less than 40, it's going to be the 31, the 44, and the 9. So it's going to be, we need to add all those together, don't we? So 31 plus 44 plus 9 is equal to 84 below 40 minutes. Okay, so 81 below 40 minutes. So if the last little part now, if I want to find out the percentage, well, the percentage is going to be the amount of people below 40 minutes, which is 84, divided by the total, which gives you the proportion. So divided by 120 times by 100. So the formula for this is 84 divided by 120 times by 100. Let's work out what that is. 84 divided by 120 times by 100 is equal to 70%. Brilliant. That is tough, okay? That is tricky. And this whole topic is tricky. As soon as you get into this part where you've got to work out the frequency density, it is tough. And that's why we're going to need to practice it. So, let's have a go at some questions ourselves. So let's just check that answer first. Where are we? So 70%, yeah, brilliant, we got there. Well done. So, pause now. I've got 2 worksheets here. Pause now and have a little go at this first worksheet. Take your time with it. Pause now and have a go at worksheet 1. Super, so I'll put worksheet 2 up on. So have a little go now at worksheet 2. And I'll pop the answers up. So mark these in green. Mark those in green. So that was quite a tricky lesson there, especially towards the end when you've got to work out the frequency density. It does get difficult. But remember, the only way to learn maths is to do it. So thank you for watching this lesson on histograms. Do make sure that you're having a go at it, and have a lovely day.